Assalamu alaikum. I am Amir Hashmi and I am here to represent my discrete mathematics project which is made by me and my teammate Abdul Rahman. First of all, I will tell you the content of our discrete mathematics project. It covers two important topics, graph theory and number theory. In this video, I will explain you the problems of number theory. If you want to see the explanation of the problems of graph theory, then you can see the video of my teammate Abdul Rahman. Now I will discuss the individual contribution of our project with you. The coding problems of number theory and slides for presentation were made by me, whereas the theoretical questions and coding problems of graph theory were made by my teammate Abdul Rahman. In project planning, first we divided the project into two parts and assigned one part to each member. We studied different websites for theoretical questions. For coding questions, we decided to code in C++. Now I will explain you the number theory problems. The problem 1 is to find the prime factorization. In this problem, I have to get a positive integer from user and display its prime factorization. As you can see in the code that I have used for loop to first calculate the even prime factors and then odd prime factors and stored these prime factors in an array named as prime factors, and in the end I print that array. Now we will move to the problem 2, which is to find GCD, greatest common divisor, using Euclidean algorithm. In this program, I have calculated GCD by using Euclidean algorithm. I have implemented Euclidean algorithm by using while loop for changing dividend and divisor in every iteration until the remainder becomes 0. Now we will move to the problem 3, which is about finding LCM. In this program, I have used the code of my previous program for finding GCD by Euclidean algorithm, and then I utilized that code in finding LCM. As you know that LCM is the product of two multiplying numbers and the division of that with the GCD of those two numbers. So I will use the code of my previous program to find the GCD. Now we will move to the problem 4, which is to find Bezoid coefficients. In this program, I find Bezoid coefficients S and T by implementing Euclidean and extended Euclidean algorithm in a single while loop. You can see that in every loop iteration, the value of S, T and dividend and divisor is changing, and I control these values using while loop. Now I will move to problem 5, which is to find modular inverse. To find modular inverse, I have used my previous code for finding GCD and Bezoid coefficients, and then I have added the function of find inverse in code to check that which Bezoid coefficient is satisfying theorem m by a minus b, and absolutely that Bezoid coefficient will be the inverse. Now I will move to problem 6, which is RSA encryption. In this program, I have taken a message from user and also encryption key from user and changes the message into numeric form by applying RSA formula C is equal m power e mod n. To calculate this formula, I have used modular exponentiation. Now we will move to problem 7. Problem 7 is to find RSA decryption key. In this program, I take odd primes p and q from user and also an integer e, which is relatively prime to p minus 1 product q minus 1, and calculated Euler's quotient, whose formula is p minus 1 steric q minus 1. And then I used RSA decryption formula, and I have used my previous code to calculate inverse. As you know that decryption key is the inverse of Euler's quotient and integer e, which is entered from user. In the end, I like to thank our DM instructor Sir Waqas Ali for giving us this opportunity and guiding us throughout the semester. Thanks.